But before I get into that, let me just let's take a step back and just kind of think about what we're doing here. So yeah, I mean, we're working on a blockchain, which is obviously going to be composed of blocks. We want to avoid a lot of the mistakes that were made by blockchain and by Ethereum with respect to having each node having to have all blockchains back to Genesis. And so we're hoping that we can be clever in how we structure things so that we can so that an individual node really only has to have a subset of the blocks that it needs and nothing more. And that actually hides some issues. If you're only going to get some of the blocks that you need, there's the potential that someone might maliciously not give you all the information you need as a way to perhaps be fraudulent. And so in saying that you're not going to have, you're just going to have the nodes you need, there's some real complexities in there. So, but we do eventually have to come down to writing code, and so we have to start saying what's in the block structure. And this is a little bit of a grab bag of different pieces, but the sender and the estimate are involved with Casper, and Casper, of course, is our way of achieving consensus. We need to be able to get back to our parent, and we'll have a hash of that, something like a Merkle tree. And one thing we didn't discuss is whether there might be more than one parent, but that's something that we'll still have to take up. What's inside of the block is going to be all the transactions that have been validated for that particular round. And so we will have the transactions, but as a way of trying to compress things, we really only need to have the hash or the signature that it uniquely identifies all of those transactions. Rules is kind of a high-level term here that really masks some very interesting thinking going on here. One of the things that we want to do is avoid having to...
Just a question about hashing the transactions. How does the hash do you any good unless you have the transaction to hash and check it against?
Yeah.
Oh, okay.
What we want to do is try and not have to send all of the transaction if we can have a more compressed means of representing the transactions. And rules is a notation or a grammar through which we can describe the transactions that are contained in this block, substantially shorter than the transactions themselves. So, I mean, we had all of this filled up with the grammar for how rules work, and there's actually two different pieces to it. It's quite involved, but this rules may not have been the best title to choose, but this is a compressed summary of the transactions that are going to be in the block. Generating criteria for rules to transactions is, as I recall, this is the way that from the compressed description of the transactions, we can generate the transactions and then do the hash. Verify the hash. Right.
Either you have enough additional information that when you add it to the rules, you can generate the rest of the transactions and then check it against the hash, or you have the list of transactions.
And then finally, we have the justifications for the transactions. And we want to not have to go back to the very beginning of all of the justifications that were involved. So there was a lot of discussions about how we can limit the number of justifications that have to be in a block structure. And there's the notion of a consensus cycle and perhaps just being able to hold on to the justifications that just go back to the beginning of that. Let's see, I guess the other stuff I was going to reference didn't make it. But there's also been notions of epochs and consensus cycles within epochs, or there's also this notion of a last finalized block, or a slight variation called a forget block. But all of those are means of pruning the blockchain that any given node would have to hold.
Right. No.
straight up sequence doesn't allow for anything in between. Less than allows, and this comes before that, but there could have been a bunch of stuff in between.
So that one, the way Greg explained it was he actually drew a less than here first. As you can imagine saying, you know, I'm going to write down this list of transactions and you have to buy it before you sell it. But you might, you know, give it to Bob or Sue or whatever. But you can sort of, the maybe a more primitive notion is just that it comes right after it, and then you can define the less than in terms of the semicolon roughly. A continuation, so this is, a particular transaction is just all the bits of the reduction of the row calculus thingy.
And that's all the information that will be needed for a transaction? Or?
That's my understanding. So one could write out these in long form, or one can write this, and then I think, I wasn't entirely clear, but sometimes you need a little bit more information to recover exactly which set of transactions obey the schedule.
And now the schedule also conveys enough information to, if you have virtual machine state, then you can. If you have the virtual machine state and you have a schedule, you can now apply the schedule to the virtual machine state to get the next state. Right.
The schedule was also, like, the reason the word rule was thrown around is because it doesn't just talk about ordering, it also talks about what transactions are allowed, right? So there was, I guess one that's not up there was basically like a case class style filtering, where this is one such thing where we're saying that this set of transactions can only happen when they're in parallel with that set of transactions. There was sort of a case class style filtering there. And then more simplistically, you can have, I guess, like the logical version of this, which was denoted, I don't know if this is too low for people to see. The same, but with an underbar to say this is the like case class style match of the transactions which are of this form are allowed.
Actually, you raise a good point, right? Because in the logical formula, you can now fill in X not just with, you can do the same predicate trick that you're, like we're doing a trick, right? We're saying, I can point-wise lift all these operations to operations on collections, right? That's the trick. And then, well, so here's an operation, and this is over something that I can collect. So I can do the same thing. So now I could put a namespace spec here, and that will pick out collections of these, right? And that's part of the, so for example, Pacific Northwest at between 5 a.m. and 9 a.m., right? And then that gets a whole bunch of them all at once. What's really good was Chris was pushing back on using, we were looking at the block structure and seeing what we needed to record on the, in terms of the transaction fees relative to when information is known at the consensus cycle. So if you take the propose, promote, join primitives along with the pressure on transaction fees against the justification length, then you don't know transaction fees until the end of the consensus cycle. And so now so now the question is, how do you justify the transaction fees that if they get put into that block, right? So it's kind of a cart before the horse problem. And so one approach to solving the problem is to put some kind of justification information on the block. But if you do that, then there's a problem because not everyone has the same justification. So you have to, there's a criteria that you have to push out onto justifications that is basically you can calculate consensus from the final justification. You can calculate a verification of consensus from the final justification, and any sub-projection is not sufficient to calculate the consensus. So that would be enough to trust cryptographically the justification information that's provided as a part of providing the transaction fees. But that may end up being too onerous. So have to think about it.
The deal is you're putting together this second block, trying to deal with the fees, and the cart before the horses. Can you sort of seal up the fees transaction with the rest of it here, or do you have to just scribble something here and seal it up on the next time? And that was also sort of what we were discussing down here.
Yeah. Go for it.
So it occurred to me that maybe an easy way to summarize what I was talking about was everything that it potentially gets included in a block has to be available for other validators to disagree with before consensus is over, right? Otherwise, that it doesn't work. So if you're going to fix up fees and things after consensus is finished, well, all of those transactions that affect the fee transfers didn't have a chance to go through consensus, right? So the validator who's in charge of building the block is the one that made the proposal and has an incentive to mess with the transactions at the end, right? The same thing holds for justifications put in after consensus with the current block under consensus. So there has to be an opportunity as soon as possible to disagree with what ended up with the block. And the soonest is the next block. I don't know what that mechanism is, but you have to have an opportunity to object. Yeah. Right. Yeah. Okay.
So some of what's in this block is in the next block?
Possibly.
We'd like to avoid that. Yeah.
Yeah, we'd like to avoid it. I'm going to go up and point here because the thing that we didn't know because we hadn't gone deeply in Casper was how, first of all, if we store any of the justification, we want to store as little as possible, right? With all of these things, we want to store as little as possible. We didn't know how much of the justification used to come to consensus needed to be recoverable next time. I just don't know the answer, right? We thought, well, if some of it does need to be recoverable next time, it needs to go in the block somehow so you can get back and trace through. But it's not available under consensus. It's not available under consensus at the time we're finalizing this, at the time we're deciding on this block. So that's the tricky bit for me, right? You may have an answer, but I don't know.
So is the idea that you would claim your fees in the next block, right? Like you're entitled to them, but you reach consensus on this block, and then you just throw in a transaction in the next block that you get your fees?
I think that came out, that got complicated enough in our session that when we ended up drawing the block stuff, we left it off. We'll revisit it later to figure out how that works. The alternative is for all of the information to get exchanged up front during consensus. Everybody can do validation. If you don't have a decay function on the fee, you can decide all this stuff during validation, during consensus, right?
If you have a bunch of messages back and forth that are not helping make progress towards consensus, then and there's no penalty for that, then consensus slows down. Yeah, that's right. They haggle over something, whatever it is, right? And what putting a decay function on it. But now the decay function can't be in terms of wall clock time, or it's much less optimal to put it in terms of wall clock time, right? Because now you have to have a network service, a network time service, which is already another issue. So we'd rather have the decay function in terms of the history, the length of the justification, because every proposal has a justification, which then has a set of proposals which has a justification, right?
And denial of service is limited by the fact that if you get detectable flip-flopping, you slash.
Yeah, exactly.
So the worst they can do is drag it out for the longest possible time and then end it there.
Yeah, that's right. But so there's two competing things here, right? One is, as soon as you put that kind of pressure, you don't know the information that you need until the end, right? Whereas if you don't put that kind of pressure, then you suffer more liveness issues. Go.
I mean, last time we talked about this, you convinced me that that having the resource and limiting the number of messages could give you liveness if there are no Byzantine faults. If there are Byzantine faults, my kind of opinion is that I can get to a state where all the messages are consumed, and you can get to a state where all the messages are consumed, but where we have different estimates for the value of the consensus, because the last messages that are consumed for you and the ones that are consumed for me are actually different because of equivocation by Byzantine validators.
So this is a separate issue. I'm not arguing that you don't get that you don't have the possibility of FLP impossibility.
Or just like a
stuck state, yeah.
Stuckness.
Well, so in every case, whether it's correct by construction, Casper, or anything, you have this possibility.
Either FLP or stuckness.
Yeah, exactly. So you're caught. But what I'm trying to do is to drive the protocol in such a way that how do I say this? FLP impossibility doesn't give any information about why Byzantine faults occur.
It only requires crash faults, and only one of them.
What I want to do is to separate. Yeah, it only requires crash faults, but crash faults and sort of bad action get lumped into one thing.
Yeah, crash faults are a subset.
Right. And so what I want to do is to separate them out, because over time, what we've seen, if what happens in the future is what we've seen historically, then networks get better and better, components get better and better, and so crash faults we can just leave to the improvement of the network. And so now what we want to do is to detect the bad intent, or at least incentivize better behavior, right? And that's what this is doing.
Sure. So I mean, I believe that you can incentivize it,
but
that doesn't mean that you have a liveness proof.
No. What you have a proof of is that you will stop making new proposals, and then with the join operator, you have a proof that you will only get down to competing proposals, and then you're up against FLP impossibility at that point.
Sorry, I didn't follow.
So if you commit the political capital as a part of making a proposal, and it doesn't get distributed until the end of the consensus cycle, you have a proof.
One of the ends of the consensus cycle. Each end.
Each end. Then you have a proof that you stop generating new proposals
on each end.
And then if you incentivize joining proposals, then every non-competing proposal will be smashed together, and so you will only finally get down to competing proposals. And now you can't do any better.
Yeah, but the issue is that like I'll be able to join some things, and you'll be able to join some things, but they won't be the same things, and like we'll have different like results for that competition.
I just said that.
Right, but it sounds like consensus failure.
No, it's the same issue. Every single one of these protocols suffers FLP impossibility.
I mean, well, no. I mean, here you don't have FLP impossibility. You just have stuckness. You just have like no more messages being allowed to be produced.
Oh no!
No more promotion. Sorry, no more proposals.
Right, no more proposals, but right. they have new promotions. Right,
but
you can promote and promote and promote, and all you're doing is just driving down. So the longer they drag out the promotion cycle against each other, the less fees they get. And so they're incentivized to go, oh, wait, I really, really would like to get some transaction fees out of this. I'm going to jump ship over to this thing, right? And now the worst that you can get into is everybody swings here, they swing there, they swing here, they swing there.
But if the proposal influences the outcome of like, you know, which block has the most score, then you just have the liveness issue there, the FLP there. But if it doesn't, then you get the stuck issue.
No, that's what I was just saying. You just get down to the swing. You just get FLP of possibility.
For the promotions.
That's it.
Because
That's right.
promotions can influence the score of blocks.
That's correct.
Okay. Well, let's talk about this more later.
Did I hear you assume that the network would make crash failures less frequent over time?
I'm just saying if historically we've seen, if what happens in the future is what we've seen historically, then we're getting better and better networks.
So, but doesn't the historical data depend on Moore's law outrunning deployments? And then in the condition where Moore's law slows down, technology improvement, the hardware level gets slower than the deployment of new devices, then actually crash faults gets more likely as it on the aggregate. Like you're going to have lots more of them because you have so many more devices.
Yeah, that one's too tough to predict because there's so many different innovations here to keep track of. I just don't think I can. I mean, you can make that argument, but I think there's too many variables to track there.
Right, which is why I brought it up. Like you just shouldn't depend on it in the proof.
Oh no! All I'm trying to do is to separate out the cases.
Yeah, but you separated out the crash faults and said we can ignore them.
I didn't say no. What I said was I want to be able to control the behavior of the bad intent. That's all. I want to incentivize good. I want to incentivize good agency. Yeah.
I think just to wrap this up, the main point was blocks are unbounded in size, and they definitely have the hash of their parent, the hash of the transactions, the rules, and a way of generating the transactions from the rules for verification against the hash. And then anything else is question mark depends on Casper.
I mentioned it earlier, which is that you can apply the schedule to the last state and get the next state. Yeah, that's right.
As sort of the symmetric point, you can also, from your current state, unapply all of the schedule to get the previous state. And that got brought up at the end as like a possible performance improvement about sort of moving between different states, about starting at the beginning of time versus starting at checkpoints versus being able to get the current state and go backwards. But we never actually made any final decisions on any of that. It was all sort of talked about near the end.